Hello everyone, so I'm Michael Spence and I'm the lead researcher on CEDAR's Lighthouse project in self-supervised and semi-supervised learning, and in this video I'm going to talk about some basic semi-supervised learning methods and some of their applications as well. So I'll start with just a brief recap of semi-supervised learning. So semi-supervised learning is a paradigm of machine learning which sits in between supervised learning and unsupervised learning. So where supervised learning uses only labeled data, this is human annotated data such as captioned images or things like that to train models, and unsupervised learning uses only unlabeled data. Semi-supervised learning makes use of both. When people talk about semi-supervised learning, they generally divide it into two different categories. So there's inductive learning and transductive learning. So inductive learning, as you can see in the diagram here, it works quite similarly to supervised learning. You take labeled and unlabeled data, and using a training process, you end up with a predictive model which can give you predictions on future unseen data. This works for both classification and regression problems. So transductive learning works a bit differently. You feed in labeled data and unlabeled data, and through transductive learning processes, you get a bunch of predictions returned rather than a predictive model. So this has some limitations. It means you can't easily generalize the information you've learned to future unseen data. Although there are ways of doing this, it's a bit more complicated than in the inductive scenario. So I'm going to talk next about some concrete examples of these two semi-supervised paradigms. The simplest example of inductive learning, and possibly the simplest example of semi-supervised learning in general, is what's known as self-training. So this is a procedure where you can take any supervised method for classification or regression and modify it so that it works in a semi-supervised manner, taking advantage of labeled and unlabeled data. So the procedure is quite simple. You begin with a small amount of labeled data. In this case, it could be images, and you use this to train a base model using normal supervised methods. And then what you do is you use this base model to label your unlabeled data, which is a process known as pseudo-labeling. And you would then take your most confident predictions made with this base model, and you would add them into your labeled data set, and then use that to train the next iteration of your model. So I have some diagrams here, which should hopefully make the process a bit clearer. So as I said, you have your first classifier, which has just been trained on the original labeled images. You take these and you label your unlabeled images in a process called pseudo-labeling. And then you take the most confident predictions made with your model. You might say you want a confidence of over 75%, for example. And if any of the pseudo-labels exceed this confidence level, you would then add it into the labeled data set. So you would combine your most confident pseudo-labels with the original labels into a larger labeled data set. And you would then train a new classifier on that, which in the best case scenario would have improved performance over the original one. And you can generally iterate this process every time, adding more and more pseudo-labels. You might do 10 iterations, for example, is a fairly standard amount. And hopefully, if your data set's well suited for the process, the performance of the model should continue increasing at each iteration. So as an example of a successful use of self-training methods, last year Facebook made use of self-training to improve their speech recognition models. So starting off with a base model, which was trained with 100 hours of labeled data, so data which had been actually humanly annotated. They managed to increase the performance of this by incorporating 500 hours of unlabeled speech data and using self-training. And they found that they had a decreased word error rate of 33.9%, which is obviously a really significant improvement, especially when no extra effort was actually needed for this unlabeled data. So this is a successful example of self-training being used, but it should be stressed that the performance will vary very much from data set to data set, and there's plenty of cases where self-training might actually end up decreasing the performance compared to just the supervised model. So self-training was probably the simplest example of an inductive method of semi-supervised learning. I'll talk now about probably the simplest method of transductive semi-supervised learning. So this is known as label propagation. It's a graph-based method of semi-supervised learning, and what it allows you to do is it allows you to spread human annotated labels within a network made up of labeled data and unlabeled data. So the mathematics can get a bit technical, but I'll just tell you now about the general kind of intuition behind this method. So if we look at the toy example here at the bottom of the slide, we have a network of data points, most of which are uncolored, but 4 of which are colored. There's 2 red ones and 2 green ones. And we'd like to find a way so that we can spread these colors throughout the network. So one way of doing this is we could pick a point, in this case 4 for example, and we could count up all the different paths which travel through the network from 4 to a colored node. And if we do this, we find here on the right, these are the paths leading to red points, so 4 to 7 to 8 for example. There's 5 paths overall leading to red points, and if we count up the number of paths leading to green points, we find there's only 4. So in this sense, we consider the point 4 as being closer to red than green. We would then color it in as red, and we would repeat this process for every point in the network until every point was labeled and colored in. Another diagram which might be useful is displayed here, so this might help you understand label propagation. This is taken off the scikit-learn user guide from one of their implementations of label propagation. So on the left here is the original dataset. You can see it's mostly unlabeled, it's mostly orange, but you have 2 labeled points, one light blue, one dark blue. And if we apply the label propagation algorithm, you can see the end result is that all points end up labeled, which should hopefully provide a good demonstration of how it works and what its end goal is. So I hope you find this quick run through of 2 basic methods of semi-supervised learning useful. If you'd like to be more involved in this project or would like to see any of the future content we'll be sharing, feel free to get in touch with me. There'll also be a link to the project page in the description of the video. So thanks very much for listening.